Today we're going to dive into lesson 100. Our objectives are to determine which consecutive integers the square root of a non-perfect square falls between. We're going to use a calculator to find a value close to the square root of a non-perfect square. And then we're going to show approximate locations of points representing rational and irrational numbers on a number line. And that's going to be a new term today, is irrational numbers. We've never talked about that before. We're going to look at some irrational numbers today. All right, now these are the kind of squares that we've talked about before. We've talked about perfect squares. 1 times 1 is 1, so that's a perfect square. 2 times 2 is 4, so 4 is a perfect square. 3 times 3 is 9, 9 is a perfect square. If you went all the way up to, let's say, 81, 81 is a perfect square because 9 times 9 is 81. So in the past, when we found square roots, we have been finding square roots of these types of numbers. Square root of 9, and we would say that that equals 3. Today we're going to encounter some numbers that we're going to find the approximate value for square roots because they aren't perfect squares. All right, let's take a look at this one. Between what two whole numbers is the square root of 29? All right, so I'm going to write out here the square root of 29. Now, we know that there is not a whole number that you can multiply by itself and get 29. But we can look at some of these perfect squares that we had on the previous screen and see which one would be closest to 29. All right, so we've got 29, right? Square root of 29. That's going to fall somewhere between these two numbers. 29 falls between 25 and 36. Well, you got to think, what is the square root of 25? What is the square root of 36? And that would mean that the square root of 29 would fall somewhere between 5 and 6. Now let's go back again here to that 25 and 26. If you had to take a guess, which number do you think the square root of 29 would be closest to? Do you think it would be closer to 5 or 6? Well, it looks like it would be closer to the 5 because the 29 is closer to the 25. So it would probably be something between 5 and 5.5. We'll explore a little bit closer a little bit later to see how close we got in our approximation. All right, here's another one. What if I had to find the square root of 200? Between which two consecutive whole numbers would the square root of 200 be? All right, this is one you're going to need to narrow down a little bit. We know that 10 squared is 100. And we know that 20 squared is 400. So it's somewhere between 10 and 20. Now, looking at 100 and 400, 200 is definitely closer to the 10 than it is to the 20. So let's try 15. If you know what 15 squared is, it is actually 225. We're just a little bit high here, aren't we? So let's try 14 squared. If you take 14 times 14, you get 196. So, 196. We have determined that the square root of 200 is somewhere between 14 and 15. And it's very close to the 196, so it would be probably very close to the 14. So 14.1, 14.2, something along that line. But if they're asking just between two which consecutive whole numbers, that would be between 14 and 15. All right, let's take a look at the next slide then. When you look at a triangle like this, hold on guys, let me back it up one here. I want to cover something a little bit before we do that. Let's take a look at that square root of 29, and then we'll get to the next slide. Sorry about that. If I really wanted to find a value of the square root of 29, let's pull up a scientific calculator here, and let's find out what a calculator says the square root of 29 is. Okay, so I typed in square root of 29, and it says it equals 5.385164807134504. Now, truthfully, that's not the exact amount, because even if you just look at this last number and you took it times itself, 4 times 4 does not equal 0. Well, we know that the square root of 29 would be 29.0000000, and on and on and on. So even the calculator has to round off the square root of 29. That's because 29 doesn't have an actual decimal or fraction value that equals it. And we're going to talk about what those types of numbers are called. So we would say that the square root of 29 equals about, and we would round it off maybe to the nearest tenths place, the nearest hundredths place. It would just depend what your purpose was in using it. So it would be 5.39. And again, notice that I didn't use an actual equal sign. It equals approximately that. Square root of 29 can't be represented by a decimal or a fraction. Now, that goes on to then the slide that I tried to show you a little bit earlier. I got ahead of myself. However, the square root of 29 is a real number. Okay, let's use, this is a right triangle. Let's use our Pythagorean theorem and let's figure out what the hypotenuse equals here. And I think you'll see what I'm talking about. If I take 2 squared and I take 5 squared, that should equal h squared. That's our Pythagorean theorem. Okay, we learned that in lesson 99. Now let's put the values with this. So 2 squared is 4. 5 squared is 25. That makes h squared equal 29. Okay? But that means h squared equals 29. In order to find h, I would have to find the square root of 29. And we just proved that we can't find it with a decimal. But see, that actually is a value, because there is something that is the length of the square root of 29, and that would be that hypotenuse. So even though we can't express it as a fraction or decimal, it doesn't mean that it's not a real number. There is a real value to it. We just can't express it. We're limited in expressing it as a fraction or decimal. So if we had to find the hypotenuse of this, this would be our answer. It would be the square root of 29. This gets us then into that new set of vocabulary I was telling you about, and that is real numbers, and then this term right here, irrational numbers. All the numbers we've talked about so far this year are rational numbers. Okay, we've had counting numbers, which are 1, 2, 3, 4, on and on and on. Whole numbers, starting at 0, and those same counting numbers then. We've talked a lot about integers. Remember, integers are positive and negative numbers, but no fractions or decimals involved. And then we've done rational numbers. Rational numbers are anything that can be expressed as decimals or fractions. Okay? Now there is one irrational number that we've talked about quite a bit this year, and that is pi. You know, there have been several times that I've told you, yes, we'll use 3.14 for pi, but that is not the exact value of pi. We've rounded it off. Or 22/7, we're going to use it for pi, but that's still not the exact value. It's a little closer than 3.14, but it's not the exact value of pi because pi is irrational. Now we can add the square root of 29. If you have a number whose square root, you can never come out to a complete decimal. It would just keep going and going and going. That is called an irrational number. Again, we proved that it's a real number because we found it was the hypotenuse of this previous triangle. But it is not rational. It cannot be made into simply a fraction or a decimal. All right, now let's put a few of these on a number line, some of these rational and irrational numbers. First of all, let's go with pi. If I had to put a dot for pi on my number line, we know that pi is close to, again, 3.1. So I would put the dot just a little bit after the 3. All right? How about the square root of 2? Well, if I use a scientific calculator and I find the square root of 2, here, let's get our scientific calculator out. Okay, square root of 2 comes out to be 1.4. Let's round it off to 1.4. So I can put a dot somewhere close to halfway between 1 and 2 and label that the square root of 2. How about 2.3, but the decimal is the 3 repeating? Well, we know if we made that into a fraction, it would be 2 1/3. So I would go 1/3 of the way between 2 and 3. Maybe, if my dot can go there. And then the last one I wanted you to do was -1/2. That would be between 0 and -1. It would be halfway. And that says describe each as irrational or rational. Okay, so let me get a different color here. We know that pi is irrational. When we did the square root of 2 on a scientific calculator, they had to round it off even on the scientific calculator. That is an irrational number. 2.3 with the decimal 3 repeating is rational. You have a decimal, and you also can make it into a mixed number, 2 1/3. And of course, -1/2 would be rational. So that's our two different types of numbers that we've talked about, all going into the group of real numbers. What I would like you to do next is go on to page 696, and let's go ahead and do letters A through F. On letter F, you are going to need to draw the number line and plot some numbers similar to what we did in this last figure, so you may want to leave that slide up. And I'll see you in class tomorrow.